Welcome to a session on linear convolution. In our today's session, we are going to learn how to perform linear convolution using graphical method for any given two sequences. So we have two sequences x of n and h of n here. X of n is given by 1, 2, 3 and 1 and h of n is given to be 1, 1 and 1. So in order to compute linear convolution using graphical method, the formula is y of n is equal to summation k tends from minus infinity to plus infinity x of k into h of n minus k. Before computing this, we need to find out the length of the output sequence y of n. The formula is y of n is equal to L plus m minus 1, wherein L indicates the length of the first input sequence x of n. So in this case, the length of the sequence, if you could see, it is 4. Therefore, I have equated L to be 4 here. Plus m represents the length of the impulse sequence h of n. So in this case, the length of the sequence is 3. Therefore, m is replaced by 3. 4 plus 3 minus 1. Hence, we have arrived it as 6. So the output, the length of the output sequence y of n is going to be 6. So we will start from n is equal to 0. Hence, in this given equation, I have replaced or equated n to be 0. So y of 0 is equal to summation k tends from minus infinity to plus infinity x of k into h of, in the place of n, I have replaced it to be 0. So 0 minus k, hence it is h of minus k. So before evaluating this, we need to sketch the given sequences graphically. So first I'm sketching the first input sequence and I'm representing n in terms of k as in the expression we have in terms of k. Therefore, the sequence starts from k is equal to 0. So for k is equal to 0, the value of the sequence is 1. Hence, I have plotted graphically like for k is equal to 0, the value of the sequence is 1. Followed by for k is equal to 1, the value of the sequence is 2. For k is equal to 2, the value of the sequence is 3. And for k is equal to 3, the value of the sequence is 1. Similarly, I have sketched h of k graphically. The h of k sequence also starts from the origin point k is equal to 0. Therefore, for k is equal to 0, the value of the sequence is 1. For k is equal to 1, the value of the sequence is 1. And for k is equal to 2, the value of the sequence is 1 again. So, to perform convolution or to find out the value for y of 0, I need to perform convolution between these two sequences x of k and h of minus k. I need to compute h of minus k from h of k. So h of minus k is going to be just the mirror image of h of k with respect to the origin. Therefore, whatever I have at the origin point, I am retaining it as such. So for k is equal to 0, I have 1. So I have retained for k is equal to 0, 1 as it is. And whatever I have along the right hand side will be just the mirror image and it will come across the left hand side in the case of h of minus k. It is simple folding operation. So h of minus k is given by for k is equal to 2, the value is 1, and for k is equal to 1 minus 1, the value is 1 again. So now we can compute linear convolution between these two sequences x of k and h of minus k. So h of minus k starts from k is equal to minus 2 and the value here is 1. But if we look at this sequence here, for k is equal to minus 2, we don't have any value at all. Therefore, I have considered it to be 0. Therefore, y of 0 is equal to, for minus 2, the value is 1. Therefore, 1 into, in this case, for minus 2, I don't have any value. Therefore, it is 0. Plus, for k is equal to minus 1, the value here is 1. In this sequence, for k is equal to minus 1, the value is 0. Therefore, 1 into 0. Plus, for k is equal to 0, the value is 1. For k is equal to 0 here, the value is 1. Therefore, 1 into 1 ends. 1 into 0 is 0, plus 1 into 0 is 0, plus 1 into 1 is 1. So, hence we have arrived with the value of y of 0, which is equal to be 1. Similarly, we have to calculate for the remaining 5 values as the length of the sequence is 6. H of 1 minus k. So h of 1 minus k can be sketched from h of minus k. if I push h of minus k by 1 unit along the positive direction, I will arrive with the value of h of 1 minus k. So look at this. H of minus k starts from k is equal to minus 2. If I push this along 1 unit towards the positive side, I will arrive with the value of h of 1 minus k. So I have pushed h of minus k by 1 unit towards the positive side. Hence, h of 1 minus k is computed. It starts from the sequence k is equal to minus 1. Hope this is clear. So for k is equal to minus 1, the value is 1. And for k, it is every single unit is shifted by 1 unit the other side. Hence, we have arrived with h of 1 minus k. For our easy understanding, I have sketched it again. So we have x of k and we have h of 1 minus k. Okay, so we have to perform convolution between x of k and h of 1 minus k in order to arrive with the value of y of 1. This is equal to, if you look here, h of 1 minus k starts from k is equal to minus 1. For k is equal to minus 1, the value here is 1. In this case, for x of k, for k is equal to minus 1, the value here is 0. Therefore, 1 into 0 plus, for k is equal to 0, the value here is 1. For k is equal to 0, the value here is 1. Therefore, 1 into 1 plus, for k is equal to 1, the value here is 1. For k is equal to 1, the value here is 2. Therefore, it is 1 into 2. So 1 into 0 is 0, plus 1 into 1 is 1, plus 1 into 2 is 2. Hence, the value of y of 1 is found to be 3. Now we need to find out for the next output sequence value, which is y of 2. So y of 2 is equal to, according to the formula, it is summation k tends from minus infinity to plus infinity, x of k into h of 2 minus k. So in the place of n, I have replaced it to be 2. Okay, so we need to perform convolution between x of k and h of 2 minus k to get the value for y of 2. So we have already have the value for h of 1 minus k. If I shift h of 1 minus k by 1 unit toward the positive side, I can arrive at the value of h of 2 minus k. H of 1 minus k starts from minus 1 for k is equal to minus 1. If I push it towards a positive direction by 1 unit, then h of 2 minus k will start from k is equal to 0. Okay, so for k is equal to 0, I have 1. For k is equal to 1, I have 1 again. And for k is equal to 2, the value again is 1. Okay, so now we need to perform convolution between x of k and h of 2 minus k. If you look at this, both the sequence starts at k is equal to 0. Okay, so for k is equal to 0, the value of x of k is 1. Therefore, 1 into, for k is equal to 0, the value here is 1 again. Therefore, it is 1 into 1 plus, for k is equal to 1, the value is 2. So 2 into, for k is equal to 1, the value here in this sequence is 1. Therefore, it is 1. For k is equal to 2, the value here is 3. So 3 into, for k is equal to 2, the value here is 1. So 3 into 1. So I have 1 into 1 is 1, plus 2 into 1 is 2, plus 3 into 1 is 3. Therefore, 1 plus 2 plus 3. Hence, I have arrived with a value of 6. Hence, y of 2 is equal to 6. Similarly, I am computing the value for y of 3. So y of 3 is equal to summation k tends from minus infinity to plus infinity x of k into h of n minus k. N is 3 here, therefore it is 3 minus k. Okay, so I need to perform convolution between x of k and h of 3 minus k. So h of 3 minus k can be arrived from h of 2 minus k. If I push h of 2 minus k by 1 unit along the positive side, I will arrive with h of 3 minus k. So h of 2 minus k starts from k is equal to 0. If I push it along 1 unit towards the positive side, the scale will be, k will start from, the scale will start from k is equal to 1. Therefore, for k is equal to 1, the value of the sequence is 1. For k is equal to 2, the value of the sequence is 1. And for k is equal to 3, the value of the sequence is 1 again. Therefore, I need to perform convolution between x of k and h of 3 minus k. The sequence starts from 0 here. For k is equal to 0, the value is 1. But for here in this case, for k is equal to 0, I have value 0. Therefore, 1 into 0 is 0. So I have skipped it. For k is equal to 1, the value is 2 here. For k is equal to 1, the value is 1 here. Therefore, 2 into 1. So 2 into 1 plus, for k is equal to 2, the value of the sequence is 3. For k is equal to 2, the value of the sequence is 1. Therefore, it is 3 into 1. So 3 into 1 plus, for k is equal to 3, the value of the sequence is 1. For k is equal to 3, the value of the sequence is 1. So 1 into 1 is 1. So 2 into 1 is 2 plus 3 into 1 is 3 plus 1 into 1 is 1. Therefore, 2 plus 3 plus 1 is 6. So we have arrived y of 3 is equal to 6. Similarly, y of 4 is equal to summation k tends from minus infinity to plus infinity x of k into h of n minus k. N is 4 here, therefore it is 4 minus k. So h of 4 minus k can be arrived by shifting h of 3 minus k by 1 unit towards a positive direction. H of 3 minus k starts from k is equal to 1. If we push it towards 1 unit along the positive side, the scale starts from k is equal to 2 for h of k minus 4. So we need to perform linear convolution between x of k and h of 4 minus k. So x of k starts from k is equal to 0. For k is equal to 0, the value here is 1. For k is equal to 0, the value here is 0. Therefore, 1 into 0 is 0. For k is equal to 1, the value is 2. For k is equal to 1, the value is 0. Therefore, 2 into 0 is 0. For k is equal to 2, the value here is 3. For k is equal to 2, the value here is 1. So, 3 into 1 is 3. So 3 into 1 is 3. So that is how I have written it here. Plus, for 3 is equal to, for k is equal to 3, the value is 1. Similarly, for k is equal to 3, the value is 1 here. Therefore, 1 into 1 is 1. So 3 into 1 is 3 plus 1 into 1 is 1. 3 plus 1 is 4. Hence, we have arrived y of 4 is equal to 4. Similarly, y of 5 is equal to summation k tends from 0 to infinity x of k into h of 5 minus k. So, h of 5 minus k can be arrived by shifting h of 4 minus k by 1 unit along the positive direction. So, if you compute it in a similar manner, y of 5 is equal to 1. So, as the length of the sequence is 6, so we have computed from 0 to 5. Okay, so we are checking out for y of 6. So y of 6 is equal to summation k tends from minus infinity to plus infinity x of k into h of 6 minus k. So h of 6 minus k, if you shift h of 5 minus k by 1 unit, so it starts from 4 here. Therefore, what happens here? So whatever we have it along here, the value, it's going to be 0. So whatever we multiply, finally it is going to be 0. So y of 6 is 0. Henceforth, for any value you substitute for n is n, that value is going to be 0. Hence, finally, the output sequence y of n is arrived to be 0, 3, 6, 6, 4, 1. Thank you.